All right,
Good to
so
go.
tonight I'm going to talk about safety in off-highway autonomous vehicles and talk a little bit about a case study about autonomous vehicles in airports. It was one of the big projects that we worked on recently pre-COVID. I'm just going to go through an introduction to Northstar, talk about safety and robotics, talk about Airfield Autonomy, then move into the Winnipeg Airports Authority autonomous Plow, and then open everything up to questions. So quickly about me, 20 years plus experience in robotics and automation, spent 6 years doing medical devices, another 6 years now on autonomous vehicles. And the biggest, two things that I've done is I built a class 3 robot for brain surgery, and then now fully autonomous snowplow for airports. Northstar, just quickly a bit about us, founded in 2016, really with the mission to automate dull and repetitive tasks in industries that have labor shortages. And if you look today, almost every industry has a labor shortage. And probably the only way out of this is through automation. We developed a full stack autonomy kit for off-highway vehicles, and we're really focused on off-highway. So ag, snow, turf, and pavement. We are not an on-highway autonomy company. What we do, 3 big things. We do autonomous system safety engineering, so full safety engineering from requirements to vehicle certifications, mission critical robotic systems development, so full stack robotics development, feasibility, proof of concept, commercial release, all inside of a quality management system. So we follow a specific process, and then AR perception systems. Image guidance is one of our core competencies. Our technology platform, built an autonomy platform for off-highway vehicles, built on QNX, Secure Vehicle OS, which is very critical for safety. We have machine learning algorithms for obstacle detection and vehicle navigation, support autonomous and lead follow modes, and we can integrate basically any application that's out there. Core technology, autonomous navigation. So we use extremely accurate GPS INS, allow customers to define where they want the vehicles to go, all inside of a geofenced area. And based on where the robots are at specific locations, the robots can take actions such as like clean up a mess, lower your plow. Another mode that we support on our platform is lead follow. Basically, it's to give a labor productivity boost. So if you are cleaning a runway at an airport, normally you've got 4 or 5 vehicles going down the runways. With our technology, you can have 1 human driver with 4 driverless vehicles deployed behind. That's enough about our company and what we do. Talk about safety and robotics. So safety and robotics, why? It's an obvious answer. If you look at 2 examples I have below, on the left, you can see an autonomous Uber Volvo that has gotten to a collision with a non-autonomous vehicle, and an autonomous Tesla that, did something it wasn't supposed to and exploded on a highway. So safety is really, really important in robotics. So how do you deal with safety? Well, there's 2 real things you have to do. So 1, you have to follow the standards out there under a formal development process, right? Just to make sure that you're doing things correctly. And 2, you develop a safety system to reduce the harm based on safety requirements that you develop. So, wow, boom. So standards, wow. Standards and what to follow. It's a big open question. And here I have a list of standards that are followed or should be followed depending on the robotic system you're developing. And I'm not going to go through this slide because there's a lot of text on here, but you can see here that there is a ton of standards that you need to follow. And wow, yes, lots of standards. So how do we deal with this? Generally, all the safety standards are derived from one mother standard called the IEC 61508. And really what it does is it dictates a formal process for design, testing, verification, all around functional safety. This requires a quality management system, you can say ISO 9001, on how you develop your code and your system. And safety is really classified at different levels depending on the standard, but they're all the same thing. You have a safety integrity level, automotive safety integrity level, ag performance level, or class 1, 2, 3, A, B, C, D. And the higher you go, it's the more stringent that your system has to be in terms of safety. So more requirements around how you develop the software, what testing you have to do, redundancies, mean time before failures in all your components. And it's really all about around risk, the hazards, and the harm to a person or to people in the environment. And this is all done through hazard analysis. So example of this, if you had a vehicle that was operating in an enclosed area, but no people would go into it, you would not have to worry about any kind of safety certification, and you would be at the minimum safety requirements that are there. So safety is a real problem for robotics, and right now you're not really required in some applications to actually follow any kind of standards. Ag is one of them, but you would have to argue the state of the art in court. So if you develop an autonomous tractor per se, and this tractor decides that it's going to veer off the field and cross a highway and cause a collision and an accident, you will be liable for what you've done. And when you go to court, they will ask you, did you follow the state of the art? And if you just put your hands up and say there are no safety standards I need to follow, you're in a really awkward and bad situation. Also now, software in terms of medical is always an issue, and the FDA dictates that the software will fail 100% of the time. So depending on the industry you're in and the standard you need to follow, it's all different. So this is pretty much a big development minefield, and you need to take this seriously in the beginning. So the suggestion is out there, you go and find help if you don't know what you're doing. So you look at UL, Underwriters Laboratory, TUV, and you talk with safety consultants to help you out in your process. So what we do at Northstar, we have our own internal QMS that we follow. We have a process that's loosely based on the automotive and ag standards. And we also follow the autonomous standards that are emerging, such as UL 4600 and ISO 13847. And then we use tools that I'm sure a lot of the audience members use. We use Confluence for design docs and requirements, Jira for task and requirements management, and of course Bitbucket for storing all of our code and doing code reviews. So the whole thing is we have system requirements, design, coding, testing, test case execution, and full traceability. And for certifications, you need to show full traceability from your initial design all the way down to your test cases. So now I'm going to switch into Airfield Autonomy and talk a bit about what we've done there. And so Airfield Autonomy, why does this matter? So what you want to do with Airfield Autonomy is you want to increase the safety and efficiency of what happens on the airfield. You want to reduce damages on the airfield and reduce incursions. An incursion is if you have a vehicle that crosses an active runway. So as you can imagine, if you have a plane that is taking off or landing at high speed full of people and something crosses into that runway, which is called an incursion, bad things happen. So you also want to reduce the labor risk. So in a snowstorm, if all of your workers who are cleaning the runways live out of town and they can't get to the airport, how can they clean the runways and keep the airport operational? And airports are ideal spots for autonomous vehicles. It is in controlled environment, an enclosed area, and it's stable. So the only people on the runway and the taxiways are the people or vehicles that need to be there. You don't have to worry about random people walking around onto the runway. So this, what it does is really reduces the safety requirements inside of these enclosed areas. And this is a video of some safety challenges at the airport. So here's the inside of a snowplow going down the runway on a mildly stormy day in Winnipeg. Now you can see that this is what an operator has to deal with on a daily basis in a snowstorm. They can't see what's going on. They've got the radio blaring with people talking. It's very hard to concentrate. So imagine doing that for 12 hours on a night shift just to keep the airport open. So this is where autonomy and safety really help. So airfield autonomy can be broken down into three stages of how it will be deployed in an airfield. You have a single robotic plow, meaning it's just like a Roomba, but in a large area. And the single robotic plow will clean the aprons, the de-icing areas, and the taxiways, and it'll still be observed and monitored by a human that's in the area. You then have the next stage, which is lead follow, where you have a human operator driving a single plow in front with N or 4, say, plows behind. And this single operator can do the work of 5 people in this lead follow configuration. And finally, the full airport autonomy. In the future, all plows, blowers, and everything that'll be on that airfield will be controlled autonomously. No humans in the loop. So regulations and safety standards around autonomy in airports. Is it the wild, wild west? Can we do what we want and where we want? Well, no, kind of, sort of, maybe. There are currently no laws governing AVs on the streets in Canada. There are guidelines for testing. Some provinces have frameworks for testing, I know in Manitoba, where I'm based, we do have a bill that's been passed around, but nothing yet that you can legally test on the roads. But vehicles must comply with the Motor Vehicle Safety Act. But on private property, you can do really what you want. There are no legal requirements to certify against any standards. But from a liability standpoint, vendors should follow the state of the art. So you're not off the hook legally. So what is the state of the art in regulations? I kind of touched on that before. The auto industry is working on its own AV standard, which is called UL 4600. The auto industry also has standards around vehicle electronics and safety, which is ISO 26262, which is based on 61508. And there are safety of machinery standards. Autonomous mining industry has also deployed AVs in mines for years, and they have their own standards. But these standards are very similar to airports and highly controlled, secure areas. So nothing in Canadian aviation regulations prohibits driverless vehicles, which was great for us. Now I'm going to just move into Winnipeg Airports Authority Autonomous Snowplow, the one we developed, and talk a bit about that program and the technology around it. So history, we got a phone call from one of the VPs at the airport and said, hey, love what you guys are doing in ag, but snow is better. So what we did is we took a look at the opportunity, jumped in 2 feet, engaged with a local OEM partner, and looked at developing a fully autonomous snowplow for runways. And we officially announced our partnership in October 2018. So now back to safety again, the key point of my talk, regulatory. So nothing in Canadian aviation regulation prohibits driverless vehicles, but Transport Canada asked the WA to draft a plan of construction operations and a land use plan and submit that to NAV Canada. And we took a safety management approach. So once we did the initial paperwork, they allowed us to have an autonomous plow that could operate on taxiways and aprons, but not on the full runway. And we took a safety management approach. So we looked at and did a hazard analysis and a risk analysis on driving a plow, an autonomous plow, inside of an apron and inside like on taxiways. And every operation that we would do on the airfield, we'd have another, what's called a HIRA, hazard analysis, to see if the technology is safe and what kind of risks were involved. So what we did is we did a rigorous hazard analysis and an operational design domain analysis to see what we're operating in. And we had 2 uncontrolled taxiways and aprons and leaf fall on the runway. And based through our hazard analysis and what the risks were, we determined we were at a very low safety level. So with that, we could design the plow with a certain level of redundancy and vigor. So the autonomous snowplow. So what we did is we took our technology platform and integrated that with a plow that the WA already had. This plow had electric over hydraulic steering system, electronic throttle control, a digital transmission, air brakes, and then a CAN bus to allow us to control the plow and the sweeper. The product we developed was basically an autonomous snowplow that used an INS or GPS with inertial navigation for navigation. And we developed a suite of sensors that would allow us to see in snow. And that was a combination of LiDAR, radar, and thermal cameras for obstacle detections. Our safety system was an integration of hardware and software that provided a single fault tolerant system capable of stopping vehicle undetected fault. And that was a fused combination of LiDAR, 3D vision, thermal cameras, and GPS. And we designed this to meet the current safety standards for automotive and autonomy. The software architecture of the plow, all based on QNX, which is needed for vehicle safety. It is a distributed system based on ROS2. We use GPS and SLAM for vehicle navigation. But the thing with SLAM on a runway in a very open field, there aren't a lot of features to use in SLAM. So SLAM basically is not that useful, where GPS is the main sensor for navigation. And then we had LiDAR, camera, and radar, and AR perception algorithms for obstacle detection. All of our code is written in C++, and which allowed us to be certified to the highest safety standards that are out there for both ag and automotive. Our safety architecture, we had a lot of redundancy. We had redundant computers doing redundant calculations. Like I said, everything was based on QNX. We had redundant CPUs, redundant geofence calculations, redundant path deviation algorithms, redundant safeties, and redundant hardware to the brakes. We also had a safety rated e-stop. So if something went wrong, an operator who was nearby could stop the plow, and we were guaranteed that plow was going to stop. I'm going to switch over to the next video. So we developed this plow over about an 18-month period. And what you see here is one of our customer acceptance tests on an uncontrolled taxiway at the Winnipeg International Airport. And this was, I think, 2020, just before COVID hit. This plow is running fully autonomous, no operators, with us just standing by and taking videos. And the plan was with the OEM and our partners was to bring this to market. But then COVID hit and closed down all the airports, which basically took that market off for the next 5 years. So the airport market right now is in recovery, and it's not going to recover for the next few years. So my last slide. So lessons learned. Safety is a mindset and a corporate culture. You need to take this seriously at the beginning of your program. If you don't take safety seriously, you can get in situations like we saw a few years ago with the MCAS system from Boeing, where these safety concerns weren't addressed, and you had, of course, fatal crashes of airplane. It's kind of fuzzy on the required standards. Like I said, there's no legal framework for certifications yet, but that is going to come. And if you're a small company, it's really hard to get hardware and software for safety. A lot of the companies like QNX and NVIDIA target enterprise customers. So as a small startup, it is nearly impossible to get this technology. I will now open it up to questions.
Content made. I actually had a question that you kind of had answered in your content there about kind of an emergency stop kind of thing, but you mentioned that's kind of in your kind of redundancy systems there. We're going to jump to a question from Babita. Babita has asked, what about IEEE 7007, also ISO and NIST have some standards?
Yeah, I'm not
familiar with
those standards. The NIST standards and the ISO, which is that ISO standard? Which is it for?
The next question we have is from John. John has asked, what other industries could you have targeted that show benefits this snowplow?
Yeah, I mean, we looked at doing on-road in cities. Just the way the technology was and our roadmap around safety and redundancy, we weren't there yet. So the first case was do the airports in a nice enclosed area, prove the technology out, and then take it out onto the cities. I mean, if you look at the city of Toronto, the budget every year is about 100. Oh, it's a very nice picture. Try that again. City of Toronto's budget is $100 million every year, and usually they go over budget. So if you could somehow take that budget and lock it into like a $40 million budget yearly, that would do wonders for the city. So our roadmap was to go from airports onto city streets and then onto highways.
We've got another question, a couple of questions that have come in. John has asked, could you use the technology for farming applications?
Yeah, I mean, we started out with farming, went from ag to grass into snow, and our evolution was just based on the markets. If we were in California, we'd be targeting high-value crops, lettuce, strawberries. But in Canada, with broad acre crops such as wheat, the margins weren't there for autonomy, so we switched into turf and then snow, but now we're back into ag.
Nice. And we have a question here from El Sanusi. I'm sorry if I've mispronounced that. El has asked, did you or others on your group have to interact with snowplow workers to help you test or design the software? What were their thoughts?
Yeah, we did. We were embedded inside the Winnipeg Airport for almost 2 years, 2 snow seasons. Skeptical. There was a lot of concern around job loss, right? They thought that we're going to come in and take all their jobs away, but that was never it. It was to give them better tools. I mean, when we were there, we saw new workers in the season take a snowplow and crash it into a fueling station, right? So there was 2 incidents when we were there when 2 plows were down and out for about a few months, right? So how do you maintain runways when you have these plows out of service, right? So it was just about, serviceability and having the labor there at the time.